LaTeX is a free and open source typesetting software initially released in 1984. LaTeX is a wrapper for another software system called TeX, which in turn was initially released in 1978, making it 46 years old as of this recording. On Debian-based Linux distributions such as Ubuntu, you can install LaTeX from system packages by installing a meta package called TeXLive Full. On Arch-based Linux distributions, you can install LaTeX with Pacman. On macOS, you can download a software package called MacTeX from the website of a TeX users group. If you are using Windows, you can try looking for a solution on this page, but it is very likely that you will be happier using Linux. I will be developing today's project using Debian 12 Bookworm. I start by installing TeXLive Full, XXD and fonts Roboto. XXD is a command line tool that you can use to display binary data in hex format, and I will be using it to debug our program's output. Roboto is a popular sans serif font that I will be using in the generated PDF files. Make sure you have the latest Go toolchain installed. As of this recording, the latest version is 1.22.0. Finally, verify that LaTeX is installed properly and that the command zlatex is available in your command line. It is spelled XELATEX. Create a file named main.tx in an empty directory and open it with your favorite code editor. LaTeX files are built using tex commands, starting with a backslash. This command specifies that the PDF we want to render uses the article document class. You can think of it as a general-purpose document type. The contents of a document go into a block starting with a begin document and ending with an end document command. Inside, put some text that will be rendered into the final document. By adding this option to the document class command, you can set the paper size to A4 and the base font size to 12 points. These two lines specify the default font for the document. This command sets the paper margin on all four sides to 2.5 cm or about an inch. Compile this file using zlatex. If everything is correct, the document should be rendered to main.pdf. As you can see, this already looks like a nice PDF document, but there is a page number on the bottom of the page. By setting the page style to empty, you can remove page numbers on this and all following pages. Now let's generate a PDF programmatically using Go. I will be using the Go programming language throughout the video, but really you can use any programming language you want, as long as you can write LaTeX source to a file and execute the zlatex command. First, copy and rename the main.tx file to main.tmpl.tx. The .tmpl part of the file name is for us to indicate that this file is a Go template and is not a generated LaTeX source file. Then initialize a Go module. I call mine moros/pdf generation. Then create a file named main.go and open it in a code editor. Start by defining package main and the function main. This means that this package will be the entry point of an executable and that the execution will begin from the main function. At the package level, parse the main.tmpl.tx file as a text template. Make sure that you have imported the text/template package and not html/template. Wrap the call to parse files with a template.mast. This way, the program will not start if the main.tmpl.tx file does not exist, or if it contains a syntax error. Then execute this template and write the result to the standard output. If you run this project, you should see the LaTeX source code written to your terminal. Now let's actually generate a PDF file from the source code. I define a function called generatePDF from LaTeX that takes a byte slice containing the LaTeX source code and returning a byte slice and an error. This function will return the binary contents of a generated PDF file or an error message if the command fails. First, I create a directory for temporary files, then another directory with a randomized path. If creating a directory fails, abort the task. Next, I instantiate a binary buffer where the spawned LaTeX process can write its error messages. The zlatex command will run with a job name command line flag. This is because we are not going to write the LaTeX source code to a file, but we'll be passing the source code directly to the compiler. This sets the working directory for the compiler process. This passes the source code to the compiler process as standard input. The error output buffer will act as the standard output of the compiler process. Finally, calling the run method of the command actually spawns the process. If there was any error executing this command, we abort the task and return an error. Otherwise, the generated PDF will be found in the temporary directory as main.pdf, and all that remains is reading it as a binary. We call os.read file and return its result. Now let's call generatePDF from LaTeX from the main function. First, we need a way to render the source code template into a byte slice. We can do it by passing a binary buffer to the execute method. Then we can get the generated binary from the buffer and pass it to generate PDF from LaTeX. If an error occurred in the process, we print an error message and exit. If all goes well, we write the actual binary straight to the standard output. If you run this program now, it will print the binary as a garbled mess. When you pipe it to XXD, it is readable, but the output is too long. Therefore, we pipe it again to less and get a scrollable hex stamp of a binary. As we can see, the output begins with a string %PDF and a version number, indicating that the file is indeed a PDF document. At this point, we have successfully generated a PDF file and read it to memory. There are many things we can do with it, like attaching it to an email, uploading it to an S3 bucket, or serving it to a web browser directly. All of these are beyond the scope of this video. If you found this video useful, please like and subscribe, and please tell me if you want to learn more about generating PDFs with LaTeX or anything else. Thank you for listening, and see you in the next video.